you again so much for joining us for our next GoAERO expert lecture. We're so pleased to have so many of you here today with us. As always, we're so pleased to have our partners, Boeing, NASA, and obviously RTX, Honeywell, Iridium, Global Aerospace, and SAFT with us, along with 25 plus organizational partners from around the world. We're so pleased to have everyone here today and so excited to share Darin Underwood, who's the Associate Director for Systems Engineering at Collins Aerospace, an RTX company. He is an aviation professional with over 33 years of experience, 7 years as a U.S. Army active duty as an avionics mechanic on rotor wing aircraft. He has 9 years commercial aviation experience as an airframe and power plant, and an avionic mechanic, of which 8 years were at Delta Airlines. He has 19 years of engineering experience now at Collins Aerospace and has worked on clean sheet programs such as the 787, the C Series, and the Global 7500 business jet. In 2013, he was awarded the Collins Aerospace Corporate Winner for Engineer of the Year, representing commercial systems. He is a graduate of Embry-Riddle and holds commercial multi-engine CMEL with instrument privileges, private pilot single-engine land with instrument privileges, and airframe and power plant licenses. Darin owns a Bonanza 836 plane and can often be seen flying around, exploring the Earth from above. So Darin, thank you so much for joining us today, and we look forward to your lecture.
Thank you to Gwen and to the GoAERO team, and really looking forward to presenting this morning and appreciate the opportunity to do that. So again, thank you. I will share my slides here and confirm that everyone can see.
Yes, thank you.
Perfect. All right, thank you. So I just want to spend maybe about 30 seconds on this introductory slide, and I chose this slide for a reason. As you can see, you've got a silhouette of a young child that's pretending to be an airplane, pretending to fly, and he or she is staring out at that airplane. But I think it's really symbolic, and it really talks about our industry and where it starts. It starts as a young child. I know it did for me, flying with my grandparents in the mid to late 70s in the airplane that they had at the time, and I'm quite certain that's where I caught the bug for the aviation industry. So I think it's a really fitting opening cover slide for this, as you've got that young child thinking about his or her future when it comes to aviation and what they could potentially do in the future. Just a quick agenda. It's kind of a jam-packed agenda. A lot of good focus areas, a lot of topic areas to talk about, but a quick introduction, which was already kind of talked about, but then a little bit about who we are at RTX and how are we broken up within our business units, et cetera. And then we'll get into some autonomous operations definitions and focus areas, talk about some advanced engineering that we're doing, and then a little bit of a dive into the computing and the networking and displays and power and how we're thinking about that in flight control and critical sensing, communications, navigation, crew support, and then finally some parting thoughts. So again, as you had heard, I've had a very very privileged career. I've had a lot of great opportunities, but I kind of took a different route to get to where I'm at. As you can see, and as you heard, I actually started out in the Army, not knowing what I wanted to do, really, and that was a good fit for me, as I delayed entry into the United States Army at 17, and I went active duty at 19, and I did that for 7 years. But so I kind of took a different route to get to engineering, but I believe it's allowed me to have the success and the opportunities that I've had here at Collins now for 19 years, having worked in military aviation and being able to work in commercial aviation. I really brought some great experience to the 787 when I worked on it, C Series, now A220, and ultimately in the global business jet, the 7500. Okay, so changing focus here a little bit. Who are we? As one RTX, we have three major strategic business units: Collins Aerospace, which I am part of, and then Pratt & Whitney. And as you can see by the picture there, think engines, think APUs. That's our Pratt & Whitney business unit. And then Raytheon. Raytheon, that name has been around for quite some time and synonymous with defense. And as you can see from some of the pictures, kind of think of the pointy objects that go very fast. And that's what our Raytheon business unit does. And we'll get a little deeper into what Collins Aerospace does, but those are our three major business units that we have. And it's all around, as you can see at the bottom, really the foundational areas of our core. That's really the way we operate and do business. Digital transformation, always thinking about the next evolution of our products, and what does that mean from a digital transformation perspective, be it from production to more of a digital factory, and how can we best serve our customers. Operational modernization, again, that kind of gets into, you may have heard of something called DPLC, or digital product life cycle. It's looking for those opportunities to really modernize and do, let's say, additive manufacturing, and be more efficient in how we not only design and develop, and how we produce our products and deliver them. And then finally, differentiating technologies. This is huge in, I think, any industry. You have to be able to differentiate yourself. If you end up staying stagnant, or you're not evolving, you're not doing R&D, then you're not really differentiating your technologies in a way that has you stand out and you could be competitive in your industry. Okay, so Collins Aerospace, just a little bit deeper dive in who we are within Collins Aerospace. We've got 6 business units currently, and we're actually in the transition of bringing our connected aviation solutions business that you can see on the right hand side of this slide into our avionics business unit. And I put the red block around the avionics business unit. That's the business unit I've been in essentially from day one. I've had the opportunity to work alongside, again, some great engineers working on great products. And there's a small subset of what we do within avionics business unit, from sensors to avionics systems and fire protection, cabin management systems. But if you go to the left, you can look at advanced structures, and you can see what we do in that business unit. And that's an exciting business unit as well, given actuation. We've got cargo loading system, pilot controls, propellers, etc. And then again, we are bringing our connected aviation solutions together with our avionics business unit. So for those that have been around for a while, if you remember the Air Rink business of maybe 10 or more years ago, that's what this business unit was. It was what we call the Air Rink business, but airport systems, information, and a lot of what connected aviation solution does is that information. It's around what's on the aircraft, what's going to the aircraft, etc. So a lot of data. Think big data, and flight aware is part of that. So think big data, just a massive amount of opportunity there with analytics, etc., that allows us to streamline or look at different ways of using that data to better architect next generation systems, etc. The last 3 business units that we have here are interiors. Again, that's exactly what you would think it is. Aircraft seating, pretty exciting business unit. I've had the opportunity to see some of our new seats in the last year, and some really cool seats, and really connected galleys that we have coming out of interiors, etc. Mission systems, heavily defense. In fact, I would say it's all defense. So great partnership with Raytheon from a mission systems perspective, and enabling our war fighters to do what they do. But mission systems, great products there as well, predominantly in a defense capacity. Power and controls, again, think electric generation and things of that nature. Power, engine controls, you may have heard FADAC or EECS, or engine control, engine electronic control systems and things of that nature. So those are our 6, really going down to 5 business units that comprise Collins Aerospace. So we've got a lot of opportunities, a lot of products, a lot of technology that's coming out of these business units. That's, again, going back to that differentiating. It's setting us up for the future, and it's allowing us to differentiate ourselves from our competitors, but also provide that value and the necessary products and solutions that our customers are looking for, especially as we think about the next generation aircraft that we're anticipating here by the end of the decade across our OEM customers. Okay, now we'll get into a bit of a deeper dive of what exactly are we thinking about uh, in Collins Aerospace as far as the future is concerned. So we have this strategic initiative called autonomous operations, and it's really focused around what we call pilot-in-command autonomy. Now, I'm fully aware and appreciate what GoAERO is doing this year with the autonomous or uncrewed vehicle that is looking at being awarded in the design competition. But I think as I go through this, there's a lot of synergies and a lot of parallels to how to think about the design of that vehicle, how to think about potential risk areas, certification areas, things of that nature. So I kind of tried to find the balance between what we're doing, which is heavily based on crewed applications and crewed design, and then also what GoAERO is looking at from an uncrewed perspective. So what is pilot-in-command autonomy? And we think of it again as an autonomous system designed to aid pilots, right? We're not looking at replacing them. We're looking at coming up with what we call, human machine pairing, or you may have heard the term HAT, human autonomy teaming. We're looking at ways of designing our next gen avionics products where the human and the machine work more closely together. Again, we're not looking at replacing the human, we're looking for those ways to have the HMI, the human autonomy teaming, be more seamless and aid the flight crew in a very specific way. And the ways we're thinking about that is really these focus areas. And you can think about these, from how are you going to think about the design for your competition, flight and aircraft systems automation. This is huge. And this comes back to this human autonomy teaming. And what are the characteristics in the systems and the automation? What do they need to look like for a future aircraft? In some cases, are there certain tasks that the machine can do to aid the flight crew? In fact, maybe there is some tasks that the machine could just do and notify a crew member of a successful, let's say, checklist execution or a successful task execution. Or maybe it wasn't, the machine notifies the crew that, hey, I've run into a problem here and I need human intervention or human help in order to complete the task. Next gen flight crew concepts. You could think of this too as just next gen concepts for what you're trying to do from with your competition. The way we're thinking about this is as we take the next generation systems to be more automated, what does those next gen crew concepts look like? We know the way pilots fly today with something called CRM or crew resource management. How is CRM, crew resource management, how is that impacted tomorrow as we think about more automation, human autonomy teaming, you're working more with a machine? So that's going to really drive next gen crew concepts. And we've got to think about that. And we're doing that through a series of what we call ConOps, or concepts of operations. And I'm going to get deeper into how we're decomposing tasks that are done today and analyzing those tasks, and then looking for those opportunities to bring automation to certain tasks and get strengthening that human machine teaming. And then the last one here is optimize crew workload and operational plans. Kind of the same thing here of how are you going to optimize, for an autonomous or an uncrewed vehicle? How do you optimize, setting, let's say, the vehicle up to be launched to go execute a mission? What do the operational plans look like for that? As you are thinking about your architecture, you're thinking about your design and your concepts of operation. So these are the things that the three key focus areas that we've got to think about not independently, but together, very much, I'll say, integrated. The flight automation piece leads to next gen flight crew concepts, leads to operational efficiency. How does that all work? So this is how we're thinking about what we call Pilot-In-Command Autonomy as part of our Autonomous Operations Strategic Initiative. Okay, a little bit deeper dive here into how we're going about that under the theme of advanced systems engineering. So I'll start in the upper left hand corner with top down analysis, and this really is looking at architectures that are deployed today, or architectures in our case that we've designed and developed, Proline Fusion being one of them. So we do a systems analysis or a systems architecture analysis of how did we do this in the past? And that's very informative for how we think about the future, especially around, a term that maybe many of you have heard of, open systems architecture, or MOSA, or modular open systems architecture. So we have to think about that, and we look to our past to really inform our future. And then once we've done that, and I know it's kind of hard to see, but there's this bubble chart here, or what we call the bubble chart, where we start to do functional regrouping, or a functional breakdown of how are we looking at communications, how is communications done today? How is navigation done today? How is, overall, just managing the flight envelope from what we call gate to gate, or parking brake to parking brake. So we do that top-down analysis, kind of that whole picture look, and start to look for those opportunities of how is our architecture for tomorrow? How does it need to be designed? How does it need to address this functional breakdown, and how we want to do it to make a more autonomous vehicle for tomorrow? Moving to the center from a flight deck concept perspective, again, it's how can we create a more interactive flight deck? How can we do that human autonomy teaming more efficiently in a way that does not increase crew workload, does not decrease safety, but then brings about the operational efficiency that our customers expect? So we're looking at doing that through human factors evaluations, and in fact, we've done some of that last year, and we're continuing to do that this year with a potential architecture that we're looking at, and some technologies that we're looking at. So we bring in a series of pilots with different experiences, and we basically run them through some test cards, some flight scenarios, etc., and look for areas of are they struggling? Is there a task that's more easy for them to execute than another task? So that's one way we're doing this iterative, or an agile type method of what I call build a little, test a little. We bring something, or we architect something, we put it in a simulation type of environment, and then we go evaluate it. We look for any gaps, any disconnects that we might have in that design, and continue to iterate that until we get it refined to a point that we're pretty comfortable with that. And then the big thing here, and I've touched on it a little bit, right, is OEM, or the original equipment manufacturers. So you got Boeing, Airbus, Gulfstream, Bombardier. We try to get their feedback as well, very, very, very early in the design. I think that's very important to emphasize that as you think about your design, as you think about what ultimately your vehicle is going to do, what are your MERS, your most important requirements? What are you trying to do? Early validation, early conversations with your end user is very important, so that you know that you're hitting on the right design. You're hitting those MERS that they're expecting, such that when you get to the end, or relatively close to the end, your design, your architecture, your vehicle, you've got great confidence that it's going to meet expectations. Effectively, another way of looking at it is you're de-risking it early on by getting that involvement with your end customers, your end users. In the upper right hand, a bottoms up task analysis. Now, you heard me talk about this on the previous slide. This is where we took, I think it was 2 or 3 different aircraft. In this case, it may be hard to see, but what we did do is this, we have a Challenger 604 business jet here. And we took the checklists and all the tasks. I think it was roughly 854 tasks. We took all of those tasks and we analyzed them, and we looked at what was the highest workload. And it came down that's really systems management throughout a full flight regime was the most task saturated, task heavy the pieces that the flight crew were doing during a normal operation. And just think about that. Very task heavy in a normal operation. Well, what happens if you get into something we call non-normals, where you get into an emergency situation? You know, that crew workload can go up quite a bit. So we did that task analysis, that workload decomposition. We looked for those opportunities. Where could we bring additional automation to a flight deck, a human autonomy teaming, in order to minimize or reduce that task saturation, especially in those non-normal or emergency scenarios? Something for you to think of as well as you're coming up with your architecture for your vehicle. Now, while it's uncrewed, what what's the potential workload that maybe a ground controller or someone that needs to interact with the vehicle, what does that task or that work composition look like? So things to think about. The system functional design, every vehicle, it does not matter what it is, has some systems on it. You know, obviously an aircraft has many systems, from fuel to hydraulics to landing gear to pneumatics. But as your vehicle is going to have systems on it, it's going to have some sort of a propulsion. It's going to have some sort of a communication type of, potentially maybe a data link. But think about the functional design of what that system and system of systems is going to look like. And then finally, you know, we did the scenario testing. So like I had talked, where we've had some simulator sessions as we've prototyped and brought functionality to our future design and how we're thinking about task saturation. We've gone through those testing scenarios, and in fact, are we reducing the workload? Are we reducing the task saturation? Are we aiding the flight crew in an emergency situation? In the lower left-hand corner, so the real world testing, this is really, to me, the most exciting piece of this. And here at Collins, we're very fortunate. We've got an upwards of 4 airplanes that we do various varieties of testing. I'm going to start kind of in the middle here with this ground autonomy test, this Cessna 206 that we have here in Cedar Rapids. Now, it's a non-airworthy aircraft, which means it's not legal to fly, which really worked quite well for the last 2 years in what we've done, which means we didn't have to worry about the airworthiness of the aircraft to go fly. So I know it's kind of hard to see, but you can see 2 pods hanging off each of the struts here. And actually, this was the very early stages of some of the taxi aiding work that we're doing, along with some other technologies that are on board the Cessna. Again, because it's not an airworthy aircraft, we could drill holes in it. We could pretty much do whatever we wanted to it, and we use it as a means to start that early validation of not only some of the communication pieces that I'll get into here, but also some of the taxi aiding pieces. We acquired this airplane last year, this 182, which is flight worthy. And that just brought up another level of now taking some of the technologies that we started on the ground and applying them in a flight environment, again, in this 182. Real quickly at the top here, we've got a 208. Now, this Cessna 208 is based out of Melbourne. Now, it's predominantly a sensors and communication navigation vehicle to test the pallets for any of our new CNS products. And then finally, we've got a Challenger 604, and I touched on this a little bit with the checklist stuff that we've done. Another way to test out and start to validate a lot of the functional design, a lot of the prototypes that we got in a Part 25 business jet. And then finally, you know, transitioning the architecture. So everything that I've talked about so far is taking place in what we call our AT organization, or our Advanced Technology Organization. And we've stood up a new organization early last year called ASA, or Advanced Systems and Architecture. So the 2 groups are working very closely, hand in hand, on as AT, our Advanced Technology Organization, takes low TRL technology and starts to mature them. Then we start to work with ASA from an architecture's perspective on what does that architecture look like? What does it need to look like for future applications? So we've got two very unique but strong organizations working together, enabling our future. Okay, so I'm going to come up a few levels here and talk about how are we thinking about how does some of this stuff deploy to an aircraft? Maybe not only today from, let's say, a retrofit perspective, but also for the future. So I'll start in the upper left-hand corner, flight deck, HMI. You've heard me talk about this. This is for what we do within Collins Aerospace and specifically the avionics business unit. HMI is very important. What does that human machine interface look like, from touch screens to what is displayed to what is not displayed? So the HMI portion is very important for what we do in Collins. And the HMI portion for what you do for your vehicle design could be important as well, just in a different way, maybe from a ground station perspective. So things to think about potentially as you work your design. What potential HMI constraints or designs do you need to think about? I'm going to actually stay on the left-hand side and go to vehicle computing. Very, very important here as well. What does the next generation processing look like as far as being able to host applications, run applications? This is something that we're exploring within our next generation processors, and how much strength, how much processing power do we need to run our future applications? So vehicle computing, processing, very important. Onboard networking. I mean, there's been networks on aircraft for decades. This is going to be even more important as we think about our next generation aircraft. How is a network distributed across an aircraft? IMA, if you've heard that term, or integrated modular avionics, is a very popular type of implementation for onboard networks and moving data throughout an aircraft. But we're thinking about, well, what does the next generation IMA potentially look like? Is it more distributed, where you've got maybe some processing that's more locally placed throughout the aircraft and not maybe necessarily concentrated in an electronics bay? So these are the things we're thinking about along, with vehicle computing and onboard networking. And then finally, power distribution. You have to have a means to efficiently distribute power to, again, the vehicle computers, the network switches and things of that nature. So this is where we're looking to, and collaborating with our power and controls business unit on how can we avionics work together to maybe package something together from a processing perspective and a power perspective. A lot of great opportunities for how we're thinking about the future. And things for you to think about too is your vehicle going to need an onboard network? I suspect it probably will in some form or fashion. Certainly not to the extent of this Part 25 wide body aircraft that you see, but you will need some sort of computing, probably some sort of onboard network, power distribution, right? Are you going to have backup power and some means? So things to think about as you work on your vehicle design. Flight critical sensing and control, so upper left-hand corner here again, we're industry leaders in vision systems with our EVS product line, our enhanced vision systems, or our combined vision systems, and being able to look through any weather out there, fog, snow, rain, clouds. So very important too, a thing to think about as you lay down and write out your ConOps and your MERS and your design for your vehicle. What kind of vision is this going to need? Is it going to need like a camera? Is it going to need some sort of radar? What kind of environment are you going to operate it in? Sensors very important too here. With our Burnsville, Minnesota business as part of avionics, with laser air data is something we're looking at in the future, or smart probes for pitot and static, angle of attack, ice detection. Not quite sure if that's something you would need for your vehicle, but certainly for what we do in Part 25 business jet and in large aviation, those are things that we always have to consider and always have to think about. flight controls is a huge one for us with fly-by-wire control systems and managing the aircraft envelope. And then radar. Radar is very important as well. Having that radar detect the weather out in front of the aircraft, turbulence, what does that ride comfort look like? Think about one of the things that we do quite well is our radar systems, and then we couple that with fly-by-wire control systems where we can dampen out any turbulence or try to damp out any foreseen or forecast turbulence based upon what the radar is seeing, along with our sensor inputs too, from our Burnsville site. Communication and navigation, very important. Aircraft today are very, very connected. That's only going to increase as we think about future aircraft around data link. One of the things we talk about quite often here with our new, or not our new, but our CAS business unit that's now coming into avionics is end-to-end communications. What does that look like from let's say a primary data link to a secondary data link? Things for you to think about too in your vehicle design. You may have heard a term of BV loss, or beyond visual line of sight. Is your vehicle going to operate in a BV loss type of environment? What does your communication architecture look like from a data link perspective? How are you going to maintain a constant link with the vehicle so that you can reroute it, or it can communicate to you, you can communicate to it? Trajectory and perf, huge. This is another one to think about, again, on what does the flight profile, the flight plan look like? Something we think about all the time on how Part 25 aircraft operate, is that trajectory and perf, and what's the most optimal route. And then finally, resilient navigation. A lot of press in the last few years around GPS jamming and spoofing. So this is a very important area for us, and how are we thinking about preventing jamming and spoofing of GPS signals? Something for you to think about as well. I assume GPS, primary means of navigation, it seems to be the primary means for most any navigation today, not only in aviation but also in the automotive industry. How are we going to deal, or how do you think you can deal with GPS jamming or a contested area? So we're working designs there as well. And then part of resilient navigation is our new radio altimeter solutions. The last couple of years you may have heard around all of the challenges with 5G coming online, and radio altimeter issues in and around airports. So resilient nav, very important. End-to-end communications, or comms, very important when it comes to communicating and navigating your vehicle. And then finally, I think this is my last major slide here, crew support. Now, for us and what we do, Part 25, fatigue detection is very important. And that really goes to the safety elements for the flight crews. And how can we detect and help them better operate their aircraft by doing fatigue detection and just notifying them, hey, it seems like you may be a little bit sleepy. So we're working technologies in that arena to aid the flight crew to have a more safe operation. And task assistance. This is a huge area. You've heard me talk about it quite a bit, but just a little bit deeper on what I mean by that. So task assistance, we're looking at enhancing our crew or our electronic checklist. The electronic checklist is pretty prevalent in our industry now, in our Part 25 aircraft. But we're looking at ways of, again, taking the electronic checklist and those tasks that pilots would traditionally have to do, of change a switch position or a knob, and then either through what we call auto sensing, that change in position would be sensed by the aircraft, and that checklist item would automatically be checked. But we're looking at expanding that, and let's say you've got a pre-flight checklist of 10 items. We're looking at going, instead of doing 10 independent items, we're looking at having the crew being able to just launch that checklist, and the aircraft would go off and execute that checklist, and either notify the flight crew of, hey, the checklist was successfully executed, or ran into an issue on step number 6 and now need human intervention. Again, back to that human autonomy team. So that's how we're really thinking about taking task assistant into the future. Those tasks that I talked about earlier, look, we did that analysis. We're looking for those opportunities, and we're actively prototyping how can we automate some of that for the flight crew so that we're aiding them during their operation, especially when you get into those non-normal scenarios where we want to be able to help them have a safe outcome. Real quick on this, just some foundational enablers, assurance and certification. Working with the cert authorities early on is very important in order to ensure success of your design and or your vehicle. Networking and connectivity, I've talked about that one. AI, ML, we're certainly looking at this from a neural network perspective and machine learning from using data lakes and taking the data that we have access to from our connected aviation solutions business. Systems integration. This is a huge one, especially if you've got multiple systems. How are you going to integrate all of those systems together? And then for us, there's the air traffic management. And depending upon where your vehicle is going to operate, you may have to consider this. What type of airspace are you going to operate in? So just some foundational enablers that we're thinking about. So my parting thoughts is, I've got 3 here. Do the work. Now you may think that that's pretty obvious, but what do I mean by that? So when I say do the work, we've all had it in our careers where you may get assigned a task that you're not, too, let's say, excited about. But if you do that work and do it to the best of your ability, yeah, that does get recognized, and you do get those other opportunities. Get comfortable with being uncomfortable. I found in my career, if you get comfortable, you tend to get stagnant and you're not learning a lot. And then this is a very important area, in my opinion, to set yourself apart from your peers. If you're working in that uncomfortable environment, you're probably doing a task that's could be challenging or difficult. And then the last thing here I have is grow your network. Networks are very important to have a very strong and prosperous career. Is grow your network of individuals around you. And I think with that, that's it.
Thanks so much, Darin. Thank you, everyone, for joining us. As a reminder, please use the Q&A function in Zoom to submit any questions you have. Unfortunately, given the number of participants, we're unable to allow you to speak directly, but please use the Q&A function or the chat if you're unable to find the Q&A in Zoom. So one of the questions we have so far is, how did you evaluate workload on the bottom-up task analysis?
Let's scroll back to my slide so I make sure So the bubble chart here, I know it's very hard to see, but the bottoms-up analysis was really a decomposition. And what I mean is that the top bottom analysis, actually, that's not the question, was it? It was the bottoms-up analysis. Sorry. Let me go back over here. So this was where we took, in this case, the Challenger 604 checklists, and really the AFM, or the airplane flight manual, and the FCOM, or the flight crew operations manual. We looked at all of those tasks, so I think 854 tasks, and broke them down and looked at them one by one. And again, I apologize, I know it's hard to see here, but you can see on the graph, these talk about each of the areas that had the highest workload, and the systems management is where the highest workload was. So it was looking at all of those tasks, all of the support manuals that are part of the certification for that aircraft to operate it legally. What are the tasks the crew are doing? Where are they most involved in having to change switch positions, change, turn a knob, etc., in order to pre-flight, taxi, fly, everything associated with operating that aircraft. So once that was all laid out, then those common areas where we bucketize them, and again, in this case, systems management being the top one, that's where we looked at that and said, here's the heaviest workload. This is where we want to try to focus our effort on first and trying to be more efficient in that area. So I hope that answered the question.
Another question is, with aircraft being more and more connected, do you foresee the low technology pre-World War II airplanes being forbidden from flying in the near future?
I don't think so. I'll use ADS-B as the example. I think, at least in the United States, the mandate, I think we're on our second year or third year of having the ADS-B mandate, meaning aircraft had to be equipped with the output of ADS-B. And essentially is if you wanted to fly any vintage, didn't matter what kind of aircraft it is, Part 23, Part 25 airplane, if you wanted to fly that airplane in the NAS, or the NAS, the National Airspace System, you had to have some sort of ADS-B on the aircraft. If you didn't comply with that, then legally you should not be flying. So, pre-World War II airplanes being forbidden, I don't think so.
With the move toward reducing pilot workload and eventually pilotless flight, how do you see this progression occurring, and where will Collins get this technology, organically or through acquisition?
Great question. There is debates day in and day out, not only within my company, but a lot of the forums and chats and companies that I follow around not only reducing workload, but what is the eventual progression towards maybe, uncrewed flight look like, or pilotless flight look like. I can tell you, and if you, I think it came out pretty clear in my presentation. Collins Aerospace is not about reducing the pilot complement, right? We're about that pilot autonomy teaming. And today, Part 25 aircraft are certified minimum 2 pilot. So that's what we're looking at, and that's where our technologies around task assistance and human autonomy teaming are really playing into. Those 2 pilots that are up front, providing a safe, uneventful flight throughout that gate-to-gate operation.
We're curious a little bit as a follow-on to that, Darin, is your thoughts on autonomous flight then, when it comes to emergency response aircraft. What role can it play, and how should it be utilized?
Certainly, emergency response aircraft play a crucial part in our industry today with medevac helicopters, medevac fixed wing. Is there an opportunity, let's say in the rotor wing segment, to aid those crews, or even when we think about an uncrewed type of medevac or emergency assistant vehicle, certainly play a part. I know when we think about uncrewed in the future, there's still a lot of, I think, some angst, and I'll say the jury's still out on how are drones going to fit into our airspace. There's a lot of things to be thought about with detect and avoid, that communication, or the BV loss, the beyond visual line of sight, and how an uncrewed vehicle is going to be operated. But it's certainly something that Collins, we are actively thinking about, especially from a connected aviation solutions business unit perspective, now part of avionics. How are these drones, or these uncrewed aircraft, how are we going to be able to work together with the crewed aircraft, Part 23, Part 25 aircraft? So something we're thinking about, definitely have to consider that. And I think there's some great technologies and great opportunities in that space of UAM or AAM or uncrewed vehicles, autonomous vehicles.
So, if there other questions, please submit them. But in the meantime, just as a reminder, we are closely partnered with the FAA, as well as Gardner Aviation. So just a reminder that those resources are available at herox.com/GoAERO. There was a lecture done with the FAA a couple of months ago that you can find in the expert lecture section, and there will be more information forthcoming, and they will be supportive of Stage 2 and Stage 3 teams going forward. Another question is, when using pilots during the test runs of new systems, how do you take the performance variance, i.e., due to experience level, ability, training, etc., into account?
Yeah, this is an area that I will say is not a strength of mine. We have a very a good, a very educated, very experienced human factors department that is leading this. And what I can say from what I understand of what they're doing is, those test runs or those performance variations, um, they're looking at not only the age and the experience of the pilots or the subjects that were running through this, and then through their methods, and I'm not quite sure what it is, they decompose that down into, for a given phase of flight or a given set of activities or tasks, you know, the demographics might say pilots within this region of age and or experience tend to struggle with tasks 2 and 3. But if you take, a more experienced pilot or a set of pilots, maybe they're older, they've got multiple type ratings, or they've got different experiences, say they've flown military, or they've flown commercial, or they've flown business. They may perform better in tasks 2 and 3, but maybe not so much in, let's say, some of the human machine interactions. But what I can say about that is what we are finding out is that the younger generation of pilots um, do much better in, I'll say, more interactive flight decks than some of the older generation pilots that grew up on old 6-pack type of instruments. And we believe that's just because of the iPhone era, the iPad era, basically the tablet and connectivity era is why we're seeing the younger generation pilots are able to adapt and be, better users of today's avionics. So that's kind of that's the way we're thinking about it and the way we're proceeding.
When you mentioned the notifications regarding fatigue, is that something that pilots have found to be useful? Is there a lot of consideration for how the notification will be perceived by the pilots?
I can tell you this is a touchy subject with flight crews, especially unionized flight crews, which all major airlines are unionized. And the reason why it's touchy is because, one, first and foremost, pilots don't like to be watched and or monitored. So we've had to have some very, I'll say, crucial or interesting conversations with certain flight crews or certain groups around, look, this is merely a means to enhance safety. It's not a way to do, punitive type of actions against you because of some performance. This is merely a way to indicate to you that one or both of you are approaching a drowsiness or a sleepiness type of activity. The way that we're thinking about notifying is we're going through those studies and how we would do that. And right now, I think the simplest thing is some sort of a message in the flight deck. If you're familiar with ICAS and ICAS philosophy from a Boeing perspective, or ECAM from an Airbus perspective, some sort of a ding or a chime or something on a display to let the flight crew know that one or both are approaching a drowsiness state.
Can you talk about some examples of redundancies or safety features that balance risk of system interruptions to autonomous flight, as in difficulties in accessing data or key function failure due to something like a solar X flare or malicious interference?
Yeah, the solar X flare, to my understanding, and again, I'm a systems guy by education and trade, right? So when we get into really the hardware design part of this and EMI, I do know we have to go through some level of testing or environmental. You may have heard DO 160 type of environmental testing that ensures that at the higher altitudes, as you get into like a solar flare type of situation, that our equipment is not disrupted by that. Malicious behavior. You heard me talk about GPS jamming and spoofing is a huge issue right now. And we're actively working that really twofold. a new antenna design that prevents jamming, and then a software type of application that can help tell the crew if they're being spoofed. Spoofing is by far the hardest because it happens very slowly over time. And we have to design a way to notify the crew that their GPS receiver is being spoofed. Jamming is very easy. You either have a GPS signal or you don't. And we're actively working and looking at TSOing here very soon, an antenna solution that will help prevent the jamming part. And we're also actively working new software for the spoofing part. As far as the examples of redundancies and safety features to balance the risk of systems interruption, these are there's some studies that we're doing through, again, a ConOps type of decomposition, but also that task analysis that I talked about on certain tasks through certain phases of flight. If there was an interruption, let's say in the takeoff phase or more of in the landing phase, what can our system do from a redundancy standpoint to either what we call play through that or coast through it, or notify the flight crew in such a way that maybe an aircraft system is taking action on to aid the flight crew. So there's some ongoing studies that need to happen here, again, on that redundancy and safety and balancing that risk.
Any other questions or comments from the community? As a reminder, also the expert lecture will be posted to our website. So if you'd like to reference these slides later or any of the questions that have been previously discussed, you can certainly review them at a later date.
I do see one other question here about being comfortable with being uncomfortable. I
Correct.
don't
Yeah,
know
absolutely.
if
If
you
you'd
can
like
see
to
that
address
one.
that. Yeah, absolutely. You recommended being comfortable with being uncomfortable. I am performing a new task that is much more challenging than similar tasks that I've done previously. Is it okay to say something to the effect of, this is the first time that I've performed the following task to the degree difficulty that has been requested?
Certainly. I would say there's no shame and or no reason why you shouldn't. If you've been assigned a task that's difficult, that one way to look at it is maybe your leadership or who assigned you that task sees that, this person's capable of accomplishing this. Maybe it is a hard task, and that leader or whoever signed it knew that going in, but felt confident in your skill set to get it done. This is an area that, again, I say fortunately or unfortunately, I've had throughout my career where I have been reassigned or I've been pulled out of certain areas that I was in to go work a difficult task. But I always viewed it as a positive. It means that, in some cases, you're being trusted by your organization, your leadership chain to go tackle that difficult task. And the one thing I will say is, at least throughout my career and for individuals that I coach and mentor, finding those opportunities to set yourself apart from your peers, that's your greatest opportunity for advancement and promotion.
Darin, I think that's all of the open questions we have so far. If we have additional questions that come in, we will certainly reach out to you and perhaps ask you to answer them offline.
Yeah.
But in the meantime, thank you so much for your presentation. We appreciate it very much. To all of our participants, as a reminder, Stage 2 registration for the competition is open. You don't need to have participated in Stage 1 in order to participate in Stage 2. So we encourage you to go to the website. Stage 2 registration documents are available on the homepage, as well as at the end of every single update that has been posted recently. So you can easily find those documents. If you have questions, you can always reach out to us at info at goaeroprize.com. And then one final question, will there be a recording or transcript included with this Q&A? There will be a recording. Yes, there will be a recording that's posted at herox.com/GoAERO under the Expert Lectures tab, and you'll find the presentation posted there, where then again, if you'd like to just get to the Q&A, you can certainly skip to the last 15 or 20 minutes of the video. Thank you again so much, Darin, and we look forward to your continued involvement in GoAERO.
Yeah, again, just a thank you to the GoAERO team. I think this was a great opportunity. I appreciate it. Hopefully, the presentation was well received, and you got some nuggets, some data out of it. Hopefully, I answered the questions completely as best I could. Again, yeah, certainly reach out to me if there's any other questions, or I'm open to any mentoring or coaching opportunities as well. I always
Great.
look forward to that.
Perfect. Thank you so much. Take care.
Thank you. Bye.
Bye-bye.